Okay, so on this one, we have a function here. Let's bring it on down. X minus 2 over e to the x. And they want us to find the relative extrema. That means like maximum, minimum, things like that. So that means you got to take the derivative, right? Because you find the maxes and the mins, the extrema, the extreme values, the highest, lowest values, when the derivative is zero. Why? Why that? Because that's when the slope is zero. Well, why does that matter? Well, if you think about a graph, for example, when it goes highest, when it goes lowest, at the highest point, say you're on a roller coaster, your slope is flat at the highest point, and then at the lowest point, your slope is flat again, right? So at the highest, lowest points, maxes and mins, your slope is flat, your slope is zero, so your derivative is zero. So we take the derivative of this function. Now, how do we take derivative of that function? We got to use what? The quotient rule, right? Because that's a two, that's division. How's the quotient rule? It means you take turns. The first one goes first, what's the derivative of that one? That's just going to be one, because this is a one power, comes on down, and it's just one. Then you subtract one, it's gone. Derivative of two is zero. Times the bottom function unchanged. Minus the top function unchanged. It's not his turn times the derivative of the bottom function. What's the derivative of the bottom function? Derivative, derivative. It's just e to the x is our favorite one. He does nothing. Over the bottom square. So bottom square. Right? You good with that? That's a quotient rule. Quotient rule says you take turns. You do the derivative of the top, leave the bottom unchanged. Minus. Just like the product rule, but it's got minus. Leave the top unchanged. Derivative of the bottom, e to the x does nothing. It's our favorite. Over the bottom squared. Okay, so there's the derivative, and we want this derivative set equal to zero because we want to know what will make that derivative equal zero. How's that derivative going to equal zero? Well, how's a fraction equal zero? If I said, hey, I got a fraction, it's equal to zero. How can you make a fraction equal to zero? Only if the top is zero. Do you realize that? Like 0/3 would be zero. But if you think, wait, what if the bottom's zero? No, that's infinity. If the bottom is zero, that's infinity because zero goes into three forever. But three goes into zero, not at all. So basically, if you want a whole fraction to equal zero, like what we're doing, and you might be, why'd you set it equal zero? Because that's what we're trying to find, right? I want the derivative equal to zero. I want the first derivative to equal zero. I want to know where does this first derivative we just took, where does it equal zero? Because that's where your maxes and your mins are going to show up. So how does this whole fraction equal zero? Well, when the top is zero, it has nothing to do with the bottom. You see that logically? The only way a fraction can equal zero is if the bottom, sorry, if the top is zero. Here, another way you can see it, just make it simple, just cross multiply. Put this over one, go diagonal, diagonal. And you'll get 1 times e to the x minus x minus 2 e to the x, right? Because it's just all, 1 times that equals 0 times e to the x squared. So that's just zero, right? You seeing what I'm saying? It's just zero. So in the end, we just end up with the top, don't we? See how it's just the top equal to zero? All right, let's work this out. This is e to the x. Here, let's yeah, to make this easier, let's put the e to the x in the front like that. And then when you have something to distribute, just put it in the front. So e to the x minus x e to the x plus 2 e to the x equals. Do you see that? Be careful with your signs. Minus e to the x times x is minus x e to the x. And minus e to the x times minus 2 is plus 2 negative and plus 2 e to the x. Okay. So what? Well, yeah, there's a lot of e to the x's there, huh? Let's factor out e to the x. They all have an e to the x. What does that leave? 1 minus x plus 2. You see in that? Right? If I multiply that, go back, that go back, that go back. Okay, great. So what? Now, 1 plus 2 is 3, right? Okay. Now, when you have two things multiplying to equal zero, the first one could be zero, or the second one could be zero. That's just logical. You track them with me. I said, hey, I'm thinking of two numbers. They multiply to be zero. How could that be? First one could be zero. Zero times anything would be zero. Or the second one could be zero. Anything times zero would be zero, right? So if two things are timesing to be zero, first one could be zero, or second one could be zero. So this one, how can e to the x be zero? It can't. There's no answers. There's nothing you could do there. If you put any, even if you put You put a zero power, e to the zero is not zero, it's one. Anything zero power is one. Put a negative power, it'd just be some number. Positive power, it'd just be some number. There's no way e to some power is going to be zero. There's no x that'll make that true. Does that make sense? There's no x value, zero, positive, or negative. E to anything never equals zero. So now it's there. This one's easy. Just move the x over there. So 3 equals x. I just jump them over. So x is 3. So that's our one critical value, which we got there. That's what they got. They got 3. But how do we know if that's a relative max or min or what? Well, to be sure what that is, we have to go to a number line. So I'm going to say, okay, okay. So I'm going to go to a number line like that. And I'm going to put 3 right smack dab in the middle of that number line. And maybe, in fact, maybe even just kind of come down a little bit like that. And then I'm going to plug in, I'm going to check something over here like check 2. And I'm going to come over here and check something like 4, right? I'm just checking numbers on either side of 3. Why? Because 3 is my critical value. I want to know if it's a max or min. Now check what? Check the derivative. Where's the derivative? There it is. That first derivative. E to the x minus 2 e to the x. So e to the x minus 2 e to x. Wasn't that it? Did I get that right? First derivative e to the x minus 2 e to the x. Yeah, that first derivative. Why? Because the first derivative is the slope. That'll tell me the slope. That'll tell me the function's going up or down. Check what? The 2. Plug in the 2, plug in the 2, plug in the 2. Hey, this one's easy. Well, I'll go to Desmos if it helps you. So, so e to the x minus 2 e to the x, e to the 2. So e to the 2, e to the 2. So I'm going to go, you go to functions, there it is. You go back to the main e to the 2. Um, minus, I forgot, what is it? It's, so right here, e to the 2, plug it in 2, right? E to the 2 minus 2 minus 2 e to the 2, minus 2 minus 2 e to the 2, minus 2 minus 2 e again to the 2. Well, there it is. You can see that last part just drops out. It's just e to the 2. 7.38. 7.38, that's plenty of accuracy. So it comes out positive 7.38, which means it's positive. It's up. The graph is going up in that section. Now let's go check the other one. How about we come in here and we go f prime again is e to the x minus 2 e to the x. We're going to take that 4 and plug in the 4, plug in the 4, plug in the 4. So go plug in 4, see what it's doing. So that power up there becomes a 4, and I believe that's a 4, and that's a 4. What do we get? Minus 54. Minus 54. So minus 54, that's negative. So the graph must be going down in that section, right? So now we know what this graph looks like. This graph must be going up and then down. So that means this is a local max. 3 is a local max. See how we found that? Because when you find the derivative, you're finding the slope. And the slope is positive, the graph's going up. Slope is negative, graph's going down. It's going up, then down. So 3 is a max, local max. So there was a lot of work. We found 3. It's a local max. And there we go.